We previously said that the limit as x approaches 0 of b to the x minus 1 over x would be equal to 1 if the base was Euler's number e. We said that that was true by the definition of e. Here we're going to look at another definition of e. For f of x is equal to the natural log of x, we know that f prime of x is equal to 1 over x, which means that f prime of 1 is equal to 1. I'm going to underline that result and we will come back to it in a couple of minutes here. Another way to develop an expression for f prime of 1 would be to use the definition of the derivative. And so f prime of 1 is equal to the limit as h approaches 0 of f of 1 plus h minus f of 1 divided by h, where we see 1 is playing the role of x in the definition of derivative. Well, we haven't used x, and instead of h here, I'm going to rewrite all of the h's using an x. So we have here that f prime of 1 is equal to the limit as x approaches 0 of the natural log of 1 plus x minus the natural log of 1 divided by x, because f of x was the natural log of x to begin with. We may recall that the natural log of 1 is 0. So we have that f prime of 1 is the limit as x approaches 0 of 1 over x times the natural log of 1 plus x. That 1 over x is a coefficient in front of a logarithm, and so using properties of logs can be expressed as an exponent. We end up with the limit as x approaches 0 of the natural log of 1 plus x to the 1 over x. Now remember, this is an expression for f prime of 1. You may recall, just a couple minutes ago, we developed a different expression for f prime of 1, and it was 1. Putting these two together, we can say that the limit as x approaches 0 of the natural log of 1 plus x to the 1 over x is equal to 1, just by equating the two expressions that we have for f prime of 1. Since e is actually e to the 1, we can rewrite using a different expression for 1, e to the limit as x approaches 0 of the natural log of 1 plus x to the 1 over x. Since the exponential function is continuous, a limit will essentially pass through it. So we can say we have the limit as x approaches 0 of e to the natural log of 1 plus x to the 1 over x. And now I have e to the natural log. Those bases match. And so we have the limit as x approaches 0 of 1 plus x to the 1 over x. And remember that this thing started with an e. And so e is equal to that limit. Another way to express that limit would be to let n equal 1 over x. And if we do that, then this becomes e equals the limit as n approaches infinity of 1 plus 1 over n to the n. So these are actually two limit definitions for e.